I really love problem solving, and I'm a person who loves board games and just thinking through problems, and I also love learning new things. And I think when I think about research, it's basically me applying the things that I love, learning, problem solving, to real life problems and to add value to the world. So basically making what I love doing useful. We're really interested in better understanding how we can wire photosynthetic materials to electrodes. And so when I talk about wiring, what I mean is to facilitate or guide electron transfer. So we're basically trying to understand how we can chauffeur electrons from one really complex system to our electrode so we can harness them for different reasons. We're developing tools which allows us to study photosynthesis in a new way. So from a molecular level to a protein level, to a electron transfer pathway level, to an organism level, to even a systems level where we have biofilms all on the surface of our electrodes and we're trying to understand how they move. Having these tools means that we can better understand how the electron transfers are regulated in nature, but also allows us to control their movements. And having that understanding and control means that perhaps we'll be able to develop technologies in which we can harness these very abundant, sustainable machineries that are available to us from nature. So akin to the way that humans have used agriculture to harness nature to feed us for over thousands of years sustainably, we want to do a similar thing, but we want to harness nature to provide us with energy sustainably. We have many different projects simply because even though it sounds like it's one particular topic, it actually touches on many fields. So we're really interested in looking at how we can better collect the electrons. So designing the electrodes, we have projects where we're 3D printing electrodes and trying to understand what type of electrodes would allow us to best harness those electrons. And then we're also on the other extreme interested in the biological systems and why and how the electrons are moving the way they are inside of these systems. And we're using lots of tools like fluorescence microscopy. We go to the synchrotron to use X-ray beams to look at them. We use spectroscopy, so a whole heap of different techniques to understand what's happening from the biological perspective. And then in the middle we have projects where we're trying to really understand and tailor the chemistry to facilitate the electron transfer at the interface. So we are designing better electron shuttles, but we're also collaborating with theoreticians to try and develop computational models to explain how the electrons are moving. So it's very diverse and varied in terms of what we do. I wasn't the first person to go to university from my family, but then again, universities and education was a very different system in my family. So my parents, for example, came from a generation in China where they abolished education for over 5 years. And so the little university education they received was very different to what we have now. So I don't think they actually even they didn't understand what Cambridge was until I actually went to it. Yes, it was a huge cultural shock when I arrived in Cambridge. I migrated to Australia with my family when I was very young, so 7 or so. And so from there that's where I had most of my education. So coming from Australia to the UK wasn't a huge cultural shock, but coming to Cambridge was because of the fact that we're surrounded by so many beautiful architecture and amazing people. And I think it was very overwhelming, and I definitely had a sense of imposter syndrome at the beginning. But at the same time, I felt like I really felt at home for the first time, because for the first time I was around people who loved learning and loved knowledge, and that's something I hadn't really experienced until I came here.